Hi, in this video we are going to learn about modulus function. Well, first of all, modulus means absolute value. And absolute value gives us the magnitude of a real number regardless of its sign. For example, while absolute value of 7 is 7, absolute value of negative 7 is again 7. So we generally relate absolute value with the distance or length in geometry mostly, or analytic geometry, because we always have the length to be positive. This is when we actually hit absolute value, but we never discussed this in IGCSE. But this is absolute value. So you use these two bars to represent absolute value, and you say minus 4 in absolute value, or absolute value of minus 4 is 4. Now what happens if we have a function? Well, if we have a function, if you write it like y equals f of x, then if we're talking about the modulus function, then we just put that function into absolute value. So what does that mean? Well, this means if f of x is positive or 0, then we can write the function as y equals f of x. If f of x is negative, then we have to write the function as y equals minus f of x. Now, you may think naturally that when there is no minus sign, whatever that expression is, it is positive. And when you have a minus sign in the front, it is negative. Well, that is not true. Now, let's consider with the simplest example. If I go like x is positive, then of course absolute value of x will be x, regardless of what value x is. However, if I say x is negative, then I have to write negative x for the absolute value of x, and negative x will be positive because x is negative. So it heavily depends on what the variable is, negative or positive. So first of all, we have to understand that just because there's a minus sign in the front doesn't mean that expression gives you a negative value, right? This is very important. Now let's see what happens with linear functions. So given this function, let's try to find the values of the following. So if we go with f of 5, this means I substitute 5 for x. So this means in absolute value 2 times 5, now minus 3 plus 1. So I end up with 10 minus 3, which is 7 in absolute value. But this is 7 plus 1, so basically I have 8. For f of negative 2, I go like absolute value of 2 times negative 2 minus 3 plus 1. And then that's going to be here, this is minus 4 minus 3. I end up with negative 7 here, plus 1. So again, it is 7 plus 1, which is 8. And for part C, I'll go like f of 1 equals 2 times 1 minus 3 plus 1, which is 2 minus 3, which is minus 1 inside the absolute value, plus 1. This comes out as 1. 1 plus 1 is 2. So basically, while trying to calculate some particular values for y, for the function, you have to make sure that you simplify inside the absolute value to a single value, single number, and then take it out from the absolute value. As in here, we have minus 7 inside the absolute value. What is it? Well, it must be 7, right? So 7 plus 1, 8. I don't do the taking out here. I have to simplify it first, right? Keep this in mind. Now let's look at how these graphs look like. So let's sketch the graph of the function y equals 2x plus 3 in absolute value. So remember that this is just a sketch, so when you draw your graph, you only need to show wherever the graph cuts the axis. Those values are enough. So if I was to sketch the graph of 2x plus 3, I would simply go with a table and then plot the points and then join them. So this is the graph of y equals 2x plus 3. Now when we introduce absolute value here, what happens is we cannot have any graph under the x-axis. Y cannot be negative. So we have this part being under the x-axis, right? These are the negative y values. So we cannot have this in an absolute value function, because when you substitute the necessary x values, you don't end up with the negative y values because of the absolute value. You end up with the positive reflection. So my graph actually would be a reflection of that part of the graph with respect to x-axis, which you can notice in here, right? So we basically have this part of the graph drawn in here. So generally, when we have a linear absolute value function, the graph will generally look like a V. And the key here is that you won't have any piece of this graph under the x-axis. We can't have negative y values. I mean, certainly I'm talking about functions which is totally inside the absolute value. So this is y equals absolute value of the function, yeah? If I have something in addition to it or taken away, then this graph may be transformed in somewhere else. That's another story. I'm talking about a full absolute value function, full modulus function. This can never be under the x-axis. Now let's switch to algebra. So how are we going to solve this equation? Now, we are going to stick to the definition of the absolute value. We're going to say this 3x minus 5, this expression will come out of absolute value either like 3x minus 5 equals 7, or, depending on the value of x, it may be minus 3x minus 5 equals 7, right? Because if x is less than 5 over 3, then this expression will be negative. And in absolute value, we have to make it positive. So we put a minus sign in front of it, okay? And I'm going to basically solve two equations. So 3x minus 5 equals 7 means x equals 4, and minus, in brackets, 3x minus 5 equals 7 means x equals negative 2 over 3. Now you may say, well, this is an absolute value equation. Why do we have a negative x value? Well, it's the expression which is an absolute value, not the solutions. Solutions may be negative. Another example. So this one is slightly different, but I will still stick to the definition. So I'll go like 4x minus 9 equals 2x plus 7, or minus 4x minus 9 equals 2x plus 7. And if I solve the first one, I'll have x equals 8, and the second equation will give me 1 over 3. Now, in this second part, please make sure that you write this expression rather than this one, because it is very important that you show that you know it's either this or this, all right? And then you can just solve this linear equation as you wish, showing as less steps as possible, like this one. Now, graphically speaking, this is what we've found. We found the intersection points of these two graphs, y equals absolute value of 4x minus 9 and y equals 2x plus 7. So this value is 1 over 3 and this value is 8. So this is what we have found, graphically speaking. Now, we have seen the graphs. We have seen substitution. We put the x values into the modulus function and find the y values. We have seen solving equations, and what is left? Inequalities. So Let's see an example of how we solve an inequality. Now, to solve this inequality, you may go visual. You can draw the graphs of these two functions, y equals absolute value of 5x minus 1 and y equals 3x. And then when you have the graphs, you can just figure out where this function is bigger than this. That's one way, but you can skip drawing the graph and basically just go with the algebra part. But even if you go with the graph, you need the algebra part for sure. The graph will just help you to visualize it. Now, let's see what we're going to do. Again, I'll be sticking to the definition, and I will be considering this as an equation first. So I'll go like 5x minus 1 equals 3x, or minus 5x minus 1 equals 3x, because I need to find where these two functions intersect. So the results are x equals 1 over 2 or x equals 1 over 8. I have these two solutions. Now, we can, instead of drawing the graph, visualize this on a number line. We can say this is 1 over 8, which is a small value. This is 1 over 2. And if you remember from IGCSE, when you have an inequality and you end up with two values, it is either in between those roots where the solution is or outside, right? So I can just test this. I can say, let's say x equals 0. What happens to the inequality? So I go like 5 times 0 minus 1 greater than, we don't know it, of course, 3 times 0. So 5 times 0 is 0, 0 minus 1 is minus 1, and absolute value of minus 1 is 1, which is greater than 3 times 0, which is 0. So this is correct. So what it means is, just because I choose my value outside the roots, I can say that the solution will be x is less than 1 over 8, or x is greater than 1 over 2. If what I found here would be wrong, then I would come up with saying 1 over 8 less than x less than 1 over 2 is the solution, if this would be wrong. Or if I test a point in between and I find it correct, then this would be the solution. So it's either this, something like this, or this. In this case, it's going to be this one. So basically, what you need to do is to just solve the inequality as if it's an equation and find the roots, and then just test a point, either inside the roots or outside the roots. And then you're going to write an inequality representing the solution, either something like this or something like this, depending on your test. So basically, this is pretty much it about the modulus function. If you stick to the definition of absolute value, everything will go just fine. Now is your turn. Please solve these questions on your book and submit your answers to the online self-checks. Thanks for watching.